I have no first name. Okay, so I have no first name. I'm just Mr. Valdez, and you can find me on Twitter, Mr. Valdez. And I'm going to talk about video games. First, who here are gamers? Please raise your hand. Nothing. A lot of gamers in the audience. Super Mario Brothers, Bullet Hell Game, and Doom. These are video games. Here in the Philippines, we have the International Game Developers Association, or the IDA, and we have a Manila chapter, and you can find us at www.ida.org/IDA, or search us on Facebook. I'm more active at Facebook anyways. Yeah, there it is, the Facebook page. So, what you need to know to program games. Programming language, math, and game programming design patterns, a game platform, and optionally a scripted language. So there are lots of programming languages for game development. Traditionally, we use too fast, C and C++, and lately we've been using C#, Flash, and Java. A scripting language is a language that changes the behavior of a program. This is a Half-Life game, which they turned into a counter-terrorist versus terrorist game on Counter-Strike. This is Warcraft 3, and they changed it into a Defense of the Ancient game, or Dota. These two are completely different games, but because of scripting languages, they were able to change the behavior. Example of scripting languages: C++, Flash, Lua, Python, and JavaScript. Custom scripting languages are Andrews-Script and Warcraft 3. Who here is afraid of math? Too bad. In the course of this presentation, you will all learn how to math. There is no escaping math in game development. So we have two topics here: coordinate system and collision detection. Let's start with the first. This is an X. The bottom one is the x-axis, and the top is the y-axis. This is 0, 0, 6, 10, 3, 5. Scary, isn't it? We map that into a game object, such as the score, a floating question mark, and our hero. Please work. Work. Does this work? Yes. Can everyone hear me? Yes. Alright. Does this really work? Alright, so we have the coordinate system. And the coordinate system is mapped into the monitor. So top upper left is 0, and the x-axis is at the bottom. We all heard of string resolutions such as 640 by 480, 800 by 600, 1024 by 768. This maps into the coordinate system. So there are 640 pixels horizontally and 480 pixels vertically. That was so hard. Now for topic number 2. Collision detection. Everyone can hear me? Yes, okay. So collision detection is very hard. Collision detection is the algorithm used to see if two sprites intersect. What are sprites? A sprite is the image of a game object. This character from Italy is an Italian plumber from Italy. And this dinosaur are sprites. Question: are these two sprites touching? We are human. We know they are not touching. But to a computer, we need math. Did this sprite touch? Yes. But to the computer, you still need math. That's what I said. To simplify the math, sprites are represented by the computer as rectangles. If a rectangle overlaps, it means there is a collision or an event is triggered. An event can be anything that can affect the game. That's an event. Now for the math. The formula to check if two rectangles have collided is this one. First box, the x plus box 1 that with and with. So, let's try to understand this mathematical formula. This is a sprite. This is the dinosaur. Our hero has a width of 10 and a height of 50. And starts at 0, 0. The monster has a width of 50 and a height of 40. And is at 100, 0. On the first test, the first plug, box 1s, which is our hero, 0 plus the width is not greater than 100. So they did not collide. Let's check this. 0 plus 10 is greater than 9. We're going to skip because I'm really afraid of math and I'm afraid of doing the formula. So if you feed this to a computer, the computer would understand that they have collided. Here, our hero have moved past by 100 pixels, while the monster is at 0, 0. The first flag checks, but the second failed. In short, these two did not collide. Wasn't that scary? Mathematics. But congratulations, you now know math. Now let's go game programming design patterns. We have the game loop and a game object. A game loop is simply an infinite loop. The word is set up, and then an infinite loop happens where the input is checked, all the objects are updated, and the objects are drawn. All games are like this. Each iteration is referred to as a frame. Now, for the game object. We have here a very simple game object in C++. We have a class of monster, and we're going to update and draw. Every frame, the game will update and draw all of the game objects. all the objects in the game can be defined as a class. We also need game objects container. This is in C++. So, a master container, or rather an object container, is responsible for managing all instances of the class. So this master container is responsible for updating and drawing the monster. Game platforms can be built, or rather programmers can build a game platform from scratch. Programmers can use whatever is available. Half-Life, Warcraft, and even multimedia fusion. Some game platforms are Half-Life, Warcraft 3, and some dedicated game platforms are multimedia fusion and Game Maker. Here are some libraries: Unity 3D, SNA, Ogre, and PyGame. PyGame, or rather, first I have to introduce Python before I go to PyGame. Python is an object-oriented programming language. It has a dynamic type system, as mentioned before, and has an interactive shell. It can be found at python.org. No other website has it. Simple syntax. To the right is C, and to the left is the Python equivalent. This has been explained earlier. As I defined with def and tabs in today's class of code. I have found new enemies. Import is equivalent to include in C++, and self is this. The double under init is the constructor. A dynamic type system doesn't care what the data type of the value is added, is assigned to the variable. So I, in this case, is integer, and this would generate a compiler error in a C++, or rather in a static type environment. For a dynamic type system, this is no problem. However, you cannot mix operation with different data types unless they are compatible. For example, you cannot divide the character S by 1, which doesn't make sense. Common Python data types are integer, float, string, list. Example of this is a open bracket, and then the values of the list, such as 0, 1, 2. We use append to add new data to a list, and remove data from a list. To control Python flows, we use the if statement, which is if condition. To iterate, we use this for loop for variable in container. PyGame is a game platform for Python. It can be found at pygame.org and nowhere else. How many time do I have left? 30 minutes. In 30 minutes, I'm going to make a game. First, I'm going to console. Where are you? And here, I'm going to open Notepad. Let's make a game. Using PyGame, Python, and Notepad. First, we need to import PyGame, of course, and then initialize PyGame, of course, and we need to generate the window 640 by 40. We need a game loop, an infinite loop, tab. This will not end well. We need to update the display. Save Python main.py. We have a 640 by 480 window. It cracks. See? That's normal. That's because we are not checking the events from the operating system. We will do that first so that it wouldn't crash. So we have an event list, and each event we have to iterate, and then we're going to check if we can quit, or rather we need to handle the quit. No more crashing.
Import this.
Oh wait, I can press
Forgot
Ctrl+C
import
here.
this.
Alright. We have a display, and it's working with the operating system. Almost. Next, we're going to create a game object. We have here images which I got from the internet. I did not draw this. This isn't very recent because this is from a tutorial. That's my excuse and I'm sticking to it. So, we're going to create a player and get an image. PyGame image load. Image // player1.gif. Player1. Next, we need to bleed the object on the screen. That's not what I wanted. So, remember this is the window, and we're going to bleed the player image, and we're going to put it at 0, 0. That's our image, our first sprite. Next, I'm going to make the sprite move. See? We need a position. And we're going to use that. The first index is the x-axis. The second index is the y-axis. Question. I want the sprite to move to the right. Should I do plus or minus?
Plus.
Is everyone sure?
Yes.
Yes. It went to the right. But we have a bug. It seems that the previous beliefs haven't been erased. If anyone here is familiar with cartoons, and if you're not familiar with cartoons, I'm very sad for you. Cartoons are done frame by frame, and every frame we change the image, or rather the frame. Here, we are going to use PyGame that fill screen. I'm sorry. We're going to fill the screen with RGB 000 or block. There we go. It went the other way. Now, if you notice, it moves very fast, right? That's because this computer is very fast. And it's an infinite loop. It looks very, very fast. So we need to limit the frame rate. We need a clock. And we're going to take 60 frames per second. It is. Every second there is 60 frames, and every frame it moves by one. And it's too slow. Let's do 21 frames per second. Still slow. Instead of +1, let's do 10. I like that a lot more. Give me a sec. That's, if you've noticed, our sprite is at the top. Let's put him at the bottom. Instead of 640 by 4, or rather, instead of 0, 0, let's move it at close to the white position. Let's say 420. Next, we're going to allow user input. So first, let's get rid of this. And we need to check if the user press the left or right button. Arrow keys. Key state. This goes to the right. Right? Move by 10. Is this plus or minus? Okay, let's give this a try. Right! Force! I forgot to add the index. See? Nobody's perfect. Let's try this again. Right! Anyone that's why that happened? The wrong index. It's supposed to be 0. Right? Left. That wasn't very exciting. I like that one more. But I can't complain. Now we need the enemies. Enemy. You are alien. interesting enemy slowing that way. I can catch it and I can kill it. So before we do that, let's make the game more interesting. We need more enemies. Now normally in a procedural based programming language, you would create enemy 1, enemy 2, and so on. But since we are an object-oriented programming language, we're going to create a class. We need an update. And we need a draw. Let's generate an enemy. Zero position. Every frame, update the enemy, and every frame, draw the enemy. Oh yes, I forgot. So this is now an object-oriented programming language. Now we can create more enemies. Let's create 2, 3, and 4. Season 5, Season 10, and Season 11. For now, let's do this. I see. Alright, there's our 4 enemies. We'll fix that later. Just to create a spawn of an enemy. And add the spawn. Each enemy data. One first. Let's make another. And another. To make it more interesting, let's add a random number. This has been shown to us a while back. Random integers let's say 0 to 30. Random numbers. Give me a sec. mic might have disappeared. So, 0, 0. And with it, we check, or rather we bleed the bullet. So let's see what it looks like. There's our bullet at 0, 0. So let's put him over here instead. We are at position 40. And every frame, the bullet will go up. Should I use plus or minus? Minus. Let's go for 5. There was a bullet, so there is no bullet. I like that bullet. It's too fast. It's not dramatic. There we go. Very dramatic. Now, if we press the spacebar button, we're going to move the bullet on the player sprite. I will explain why I'm doing this. You know what? Alright. Space button. Take note it's not directly at the turret. So we have to tweak. We can try adding 13. No. 25. Still no good. 41. There we go. 41. Now I'm sure you saw the. Yeah, this is close enough. I'm not gonna cancel. So if you notice, when we started the game, there's a bullet that is already on the screen. We have to somehow hide it. We game programmers love to cheat. Yes, it's true. So we're going to put the position at negative 1000. There's no way we could see it now. See? It's not there anymore. Now for the hard part. Position direction. You've seen the math. And we need to get the width of our image. The image width is 9. 9. That's 2. We're supposed to check the enemy. We're going to put this here. Down. Size of our enemy is 80 per win. The shot is 80. The height is
collision, whether it will remove the enemy from that container. This works because I'm running out of time.